last time we were looking for disk IO and .c, sfs.c and sfs.h. I think these three files that I need to like memorize, not memorize. I need to understand fully like
Yeah.
what's going on.
So this header file is just giving you a bunch of useful numbers, so you don't have to calculate everything yourself, right? So it's just where on disk you can find like the root directory and the block table, etc.
Yes.
And you need to put the code into sfs.c that reads from this disk. So when you read the root directory, right, it reads this big chunk of data at the start, and you have to interpret that and say that that's not just zeros and ones, that's this list of SFS entries, right?
Okay. Yes.
So if you stick to the first slide, I think it'll be
yes.
make more sense, right? So you've used the function diskread, and you've given it the offset of the root directory and the size of the root directory, and it's returned this big chunk of data into a buffer.
Yes.
And you'll need to malloc space for that buffer, or calloc space for that buffer.
Okay.
So you need to make sure there's space in RAM for it. So you read this disk, and it's this big chunk of data, and you need to say, well, that's an array of SFS entries, and you need to walk through each entry and read like the file names, right? And then they've given you a function called filler, and you can use that to write the file names to the operating system and tell it what they're called.
So hold on. So okay, I have SFS entries. That SFS entries is my file names. But what like
yes.
if you can give like an example like desktop and if you go down and until FS.
Yeah. So like that was the reason we wanted to try and mount it so we could take a look. But basically, in this test image, you've created the file README.
Yes.
You've got a folder called foo, and you've got a subfolder in foo called bar or baz, whatever it was, right?
Yes.
So the layout of that directory, right? You've basically got the root directory, which is / and it contains it contains a folder called foo and a file called readme.rst, and foo contains a folder called baz, or whatever it was, right?
Okay.
So just to make sure these are folders, I'll put slashes after them, just because it's a bit easier to interpret it.
Okay.
And at the top, I'll instead of just having that, I'll say root, which is equal to / right? They're the same thing. So you've got this layout,
slash,
right?
Root that means slash, right?
Yeah. Root and / are the same thing. So the root directory is just called /. It doesn't have a name. It's just /.
Okay.
So that is your layout, right? So when you read the root directory, when you use diskread to read this big chunk of data, it will contain two SFS entries. It will contain an SFS entry with a file name foo, that is a directory, and it will contain another one with a file name readme.rst, which is a file.
Okay.
Right?
Yes.
And that's all it'll contain in it. So baz is somewhere else on disk, right? It's not here.
Okay.
So you need to loop through these and say if it has a file name, or if it's got a size or whatever, right? If it's got a first block, then interpret it as read the file name and tell the operating system there's a directory called foo and there's a file called readme.rst, right?
Now, yes, I understand this part.
Mm-hmm.
I'm gonna loop through, but there's I'm gonna look file names, and I'm gonna interpret them as what they are.
Mm-hmm.
Okay. Yes.
So now the variable called first block is going to become useful, right? So the data segment, this big chunk at the bottom here, this one, this is divided into segments that are, I think, 512 bytes long, right? That's in the header file. It tells you how big that is.
I think yes, 500.
Yeah.
No.
So it's 8 megabytes, and inside of there, it's split into chunks that are 512 or something like that, right?
I think 4,000 times 512 megabytes.
Yeah.
Bytes or bytes.
Bytes.
I remember
It'll have it in here somewhere. So
Yes.
block size is 512. Yeah. Okay. So each of these blocks is at a certain location, and the first block variable tells you what offset that block is at. So if your first block was, they start from 1, not from 0, so you need to subtract 1 and do some maths with it, right? But that's explained in the header file. So if you say the first block, right, if it's first block, it'll be this piece of data here.
Yes.
And you need to use disk read to read just that block. But maybe it's not that one, maybe it's the second block that you need to read, right? Maybe it's over here. And your README file will be all over the place, right? So the first part of the README file might be here, the second part might be over here, there might be something down here, which is the third part of your README file, right? So what you need to do is find where all these bits are. So the first block will tell you, for README, right, first block will say, I'm up here, right, that's my first block. And then you use the block table to find out where the next one is. So you go into the block table and say, if my first block is 1, how do I find this? What's the next block? And it will say 2. And you say, okay, well then I need to jump here.
But
And that's position 3 or something, right?
this block table is already written.
Yes, it will be, well, you will need to update it. When you've created your disk image, that's all done for you.
Yep.
But when you create and delete files and folders, you need to update as well. You'll need to change that. So the block table is basically just, it's a list of how you navigate a file system. So you jump from block X to block Y, and from block Y to block Z, right?
Block table, like is it 32 kilobytes? Like I think it's
Yep. And it's just a list of numbers, right? But you can navigate that. So you say, if I'm reading block 1,
yes.
go to the block table, go to the offset, the index 1, and tell me what the number there is. And it'll be the number, I don't know, 22 or something. And then to read the next part of your file, you
Yes.
have to go to block 22. And then you read the data there, and you go to the block table again and say, I'm reading block 22, what's my next block? And they'll say block 4. So you go to the data, and you read block 4, and you go to the block table and say, I'm at block 4, what's my next one? And it might say, that's the end of the file. Or it might say, jump to 57 or 112, right? Whatever.
Okay.
Is that making some sense?
Yes, but so block table is here, 42 to 44, and in sfs.c where, no, in disk.io.c. So there is there.
Well, that's what you use disk read. So you use disk read and you tell it, go to the block table offset and read the block table size.
Go to the block table offset and the
Yeah.
size. I think offset is plus this 2.
Yes, but it's the variable's already calculated for you.
Oh.
So
Okay.
all of these offsets and stuff is already done for you in the header file. So sfs.h. So it already tells you the offset is the root directory offset plus the root directory size.
Oh, it's so good.
Right?
So good.
Yeah, so you don't need to calculate any of these things. They're all done for you. So all you need to do is say that, like, when you want to read the block table, you just go to the block table offset and you read the block table size. Right? And then you'll have a buffer with all that data, and that's made up of block table indexes. So if you scroll down a little bit, you'll see that you have a type called block table index. Keep going. Right there. So type def above this. Yep. There. So you have a type called block table index, right? And that's just a number. So you say, if I'm reading block X, go to block table at offset X, so jump X, this distance into the block table, and just tell me what number is there, and it'll tell you it's number Y. So you go to position Y at data, right? And you read that data next.
I don't get it. Why am
So like your file is going to be split up all over the place, right?
Okay.
So
yes.
it's not going to be one long. So when you saved README to your disk,
Yes.
it's probably not going to be one long piece of data.
And like you said
It's
in
going to be
here,
written.
it can
Yeah,
be.
it's going to be all over the place, but
Yes.
you don't know where that is. All you know is that the SFS entry tells you where the first block is.
Yes, this one.
So you can use disk read to read the first block, and then you use the block table to find out where the next block is. Right? So then you have to use disk read to get all the data in the block table, and you say block table. I want to go, because it's an array, right? You can think of the block table as an array of block indexes. You can go to block table at position X, and that will give you a number Y, and then you can disk read at data at position Y.
You mean X will not Y like a this?
Just numbers, random numbers. No,
X-
just whatever. PQR, whatever. ABC, doesn't matter.
Okay, so I'm first block. I got this.
hmm
So this one is this one.
hmm Block index, the right hand one.
I'm going.
So that's just a number. It's just a 16 number. That doesn't matter, right? All you need to know is that it's just when you block table, you will get an array of block indexes,
Now I
Right?
understand. Okay, this
and
one.
you just need to. Yeah, you just need to say that if your first block is position X, just go to the array at position X, and it will give you a new number, Y, and you can go to the data at offset Y and read that, and that's the next part of your file, right?
I'm gonna go in here and give it my first block, and my first block will tell me where's the second block,
Yep.
and I'm gonna go to find the second to locate second block. And how the second block will find the third block?
You go to the block table at the whatever position you just got given, right? So if the first block is at position 3,
Yes.
then you read data at offset 3. You go to block table and say, what's at position 3 in the block table? It gives you the number 10 or something.
Can you give me a second? I don't care. I have no place.
Okay.
I have no place to go. I'm sitting in here, trying to talk with you. I don't know.
You've not got headphones or something, no?
I have headphones, but it's just have problem with like you're gonna understand. Yes. Can you hear me right now? No? Can. Yes. Okay. Yes. Okay. I think I'm paying the school. I don't care.
You're muted.
So do you hear me right now? Hello?
Hold on. I don't know if you can hear me,
Yes, I can hear
but
you.
you're
right now.
muted
Oh, okay. I'm muted.
on Google Meets.
Yes. So
Yeah, okay.
no problem. I need to understand this. Yeah. It will take my time. If I can't get this, it's gonna take my 3 days.
Yeah, I don't know if there's anywhere better you can go with uni.
Yeah,
You could go to the canteen or something. She probably won't shout at you there, but
Like how many people in here? Oh. Okay.
no, it's just at the moment it's pretty empty.
Maybe I can go to canteen then really fast.
Yeah, you can just carry us across there, and then maybe it's easier. At least you won't get shouted at. I don't want you getting in trouble for attending class. So.
Maybe they can stay here. Just my phone and here. It's okay.